Good morning, everyone. Today, I'm going to go over just a little bit of what you need to know for the questions that you are going to get on exam number 2 regarding Venus and Mars. So Venus and Mars, and a little bit of Mercury, which is in the slides as well, are the last two terrestrial planets that we're going to study. One closer to the sun than the Earth, one farther to the sun than the Earth. There are a lot of features like volcanoes in both. There is a resemblance of ancient tectonic plate activity in Mars that we can discuss, and it's in the slides and in the book. But I think it would be a best idea to just talk to you guys about why do we care about those planets, what are the main differences, and what do they look today, right? For example, Mars nowadays has a surface that looks more like a desert. And you probably noticed that reddish color, right? So the simple explanation of why Mars is red is because it has a lot of rocks, right, that are made of iron. And due to the exposure, since Mars has a very thin, almost well, not it's not like it doesn't have an atmosphere, but it has a very thin atmosphere, right? Then there is a lot of exposure to radiation, cosmic radiation per se, that we here on Earth we will be exposed to that without the atmosphere and the ozone layer, right? So and the magnetosphere, of course. So obviously the iron in the rocks gets oxidized. So then, as when you have a metal outside for so long, during rainy days or very dry, imagine a whole year leaving your bike or leaving anything outside, it will become very rusty, right? So it therefore becomes a bit reddish, right? Now, it's also important to notice in terms of Mars that the atmosphere is very different to the one we have here on Earth. And it's also very different to the one that is on Venus. The main difference will be that, as you know from the previous chapter, no, the previous chapter when we talk about the Earth, chapter 8, the atmosphere on Earth has different layers. We live in the troposphere, and it's mainly composed of nitrogen and oxygen. And then you have other gases like carbon dioxide, carbon monoxide, water vapor, and methane, and ozone, right? But in the case of Mars and Venus, the most, or especially for Venus, right? You have a heavy composition, you have a lot of abundance, of carbon dioxide, which actually enables Venus to have a strong greenhouse effect. It's so strong that it makes Venus to be the hottest planet in the solar system. It doesn't matter that it's farther than Mercury is to the sun. It's because that dense atmosphere of carbon dioxide, besides the sulfuric acid rain that falls onto the ground, and that explains why when we send reconnaissance missions to Venus, like the Venera missions, we lost track of them as they were going and heading towards the surface of Venus, because we didn't know that there was, talking about like what, 50 years ago, 40 years ago, we didn't exactly know the composition of the atmosphere. Now you know there are several techniques like spectroscopy, right? But now, but back then, we didn't know. So any mission going into Venus was lost due to the heavy acid rain. Now, acid rain also happens here on Earth, by the way, but it's not like it's gonna hurt you. It's just that the pH of the rain is very low. So when you say that water is acid, it's just the pH. But there in Mercury, we are literally talking about sulfuric acid, right? So in Venus, right? So let's show you the slides. I talk a little bit, always to introduce a little bit what we're gonna talk about. but chapter 10, by the way. Venus, Mars, and Mercury. So the first thing we need to know about Venus, for example, about Venus, is that Venus and Mercury, they have the inferior and superior conjunctions, right? You guys did that in the orbits lab. When Venus, the Earth and the Sun are aligned, you get either inferior or superior conjunction based on how far or how close Venus is. Now, a good property of Venus that you should know is the fact that Venus is the brightest planet that you're gonna see in the night sky, depending on the year, depending on the time of the year, of course. For example, right now, when I'm making this video, it's November 2020, a horrible year, right? But anyway, right now in the night sky, we can see Mars very clearly. It's not brighter than Venus, though. We know that by magnitudes in astronomy, but it's there. It's probably more noticeable than Venus because of the reddish color. And that's because right now, Mars is in opposition. So that's important, right? To remember that. Now, there's a table that they give you here with Mercury, the mass of Mercury, the density, which we know is high because it's mostly made of rock. Venus there, just to compare. You guys measure the orbital period in the Venus lab. You know that there are phases of Venus, just like the moon, but the period for those phases is not a month. It's almost more than a year. That's because with Venus, right? Or basically, that was discovered by Galileo. That is one of his discoveries. But also because it depends on how light gets illuminated, how Venus gets illuminated from the sun. You're gonna see that with Mars, there are not phases. Well, there are only a couple of, maybe 3 phases. That's it. Waxing gibbous, waning gibbous, crescent, and full. That's it. Right? There's not really more than that. And then you have the Mars data. Lower density, but that has to do also with the mass. Right? The mass of Mars is, well, I would say it's 10% of the mass of the Earth. Right? Because the mass of the Earth is approximately 6 and 10 to the 24. So not bad. And the mass of Venus is almost the mass of the Earth, which actually brings into question, right? The gravity of Venus is 0.91. So when you guys are asked, right, which planet is the most alike planet to the Earth, it's actually Venus. Mars is very small. It has a very low atmospheric pressure, obviously, and its mass is 10% of the mass of the Earth. And also the radius. Let's see the radius of Mars. So the radius of Mars actually is not that bad, right? Because the diameter of the Earth is actually, no, yeah. The radius of Mars is, the half of that is 3,500 kilometers. No, 3,300 kilometers. The radius of the Earth, however, is 6,400 kilometers. It's almost double, right? So, okay. So something about Venus that you should know is that Venus has a retrograde motion. But we are not talking about the retrograde motion like Mars, when it's going to the west and then goes to the east and then goes to the west back, right? Due to the difference on the orbital speeds of the Earth and Mars. You guys should know that. That's something that you guys will do in the lab of Mars. So what can we say about this particular motion? That the orbit of all the planets around their axis are on the same direction as the way they orbit the sun. We call that prograde rotation. In the case of Venus, it has a retrograde rotation. So it's rotating in an opposite direction as it's going around the sun. Now, you know something about Venus's rotation? So Galileo, with a telescope, he was able to identify the phases of Venus, but he was not able to do the same with the rotation period of Venus. And the explanation is probably not very obvious, but it has to do with the dense atmosphere of Venus, which creates a strong dragging motion between the surface and the atmosphere, of course. So Venus is rotating very slowly because of that dense atmosphere, among other factors, but that's one of the main ones, okay? So going about Venus, because we're going to talk about Mercury, we know Mercury has an inner core, a liquid outer core, it has a mantle and a crust, very similar to the Earth. The main difference would be that the relative size of the solid core, iron, is bigger in Mercury than on Earth, okay? Now, this is very important. I added this slide in this section. So the terrestrial planets and the large moon had an extended period when they were mostly molten, like you are seeing there, all right? The heating that led to this condition was caused by impacts. Impacts of what? Planetesimals, comets, asteroids, where the kinetic energy was of the impacting material was converted. So it makes sense, right? And actually, I didn't explain this in the Earth lecture, and that's my bad. But I didn't ask you a question, but I might ask that question in the exam. In the Earth lecture, I didn't mention where does the water from the Earth come from, the water of the oceans. And why is it so salty? Because of the high mineral composition, right? But where is that coming from? So now we know the most accepted model slash theory slash explanation is the fact that comets from the Kuiper belt, from the Oort cloud, and also from the Kuiper belt, they impacted the Earth. That explains what we just read in there, but also explains that they melt as they crash onto the Earth. And comets are mostly made of dirty ice. We call it dirty ice because of the high mineral composition. So there you go. The water from the Earth was made of a high bombardment of comets. However, I did mention later in the moon lecture that there is a period around 4.5 billion years ago when the Earth was formed, also the moon, where there was a high bombardment, right? There are two high bombardment periods for the moon. They correlate with the ones on Earth, all right? Because of the large amount of planetesimals that there were at the beginning of the formation of the solar system. So obviously, the heating of this molten state has repercussion on the internal structures of tectonic plates and the composition of the planet itself, the surface features like craters, the composition of the atmosphere. Remember the atmosphere, for example, of Mars, also from Earth, have changed. For example, Mars atmosphere used to be much thicker with a strong greenhouse effect. But there was a change that must have occurred due to the loss of atmospheric gas. Much of the gas was probably stripped away by the solar wind. When the solar wind that we know ignited the sun, after the ignition of the sun, most of the gas was probably stripped away, which was able to reach the atmosphere as Mars cooled and lost also the magnetic field that it had. Water was probably lost as ultraviolet light broke apart water molecules in the atmosphere. So that's why the ozone layer is so important for us, right? There are other explanations that you're probably gonna find. Like for example, that Mars used to be a livable planet because, yeah, they both happen to be in the Goldilocks zone. Goldilocks is just the idea of a planet not too far, not too close to the neighboring, to the hosting star. So for example, for a red dwarf, we are normally excited to find planets nearby red dwarfs because those are the most, the stars that have a largest period of life way more than the sun, in some cases even to trillions of years, because the way they ignite, the way they consume their fuel, their hydrogen fuel is very, very slow. And also because of the stability, right? So there. So I talk about, yeah, right? So the first missions to especially Venus were demolished. Sorry, okay, about. Sorry about that, guys. So we have the Mariner, right? We have Venera missions for Venus. For Mars, the most recent ones will be, well, we have the Pathfinder, the Opportunity, Curiosity, right? So we have several missions to Mars, which actually is due to our very large interest we have for the red planet. Now, you're probably thinking, well, if Venus is more like the Earth, why we are more interested on Mars than Venus? Because believe it or not, it's more likely that we can land a mission on Mars than on Venus because of that dangerous, dense, sulfuric, acidic atmosphere. It's very poisonous. So it will be very tricky to do that. And also it's very hot. So, I mean, yes, Venus is more like the Earth in terms of the general properties, but Mars seems to be more like the planet where we can have bases, maybe in 50 years from now, right? It all depends on NASA and SpaceX nowadays. So remember that because of the lack of the atmosphere, right? Mars is very cold and dry. And this is very important. When I discuss about the Earth and the Moon, you probably remember, by the way, here you see, you can watch theaters of Mars, but because of the strong dust storms that normally begin on the caps, northern cap here, they can cover the whole planet. Look, between June 26th and September 4th, a planet-wide dust storm now obscures the entire surface of the planet. You probably remember the movie The Martian. Remember how the astronaut gets trapped in Mars by that accident that they also killed him? That's one example of those strong and very dangerous dust storms. If we land on Mars and there is a dust storm, it can potentially endanger the mission. So what can we say about the lack of atmosphere? So the reason we have an atmosphere is the reason we have a greenhouse effect, because of the carbon dioxide. It traps infrared radiation, so it keeps our planet warm. Now, with Mars, even though Mars is also in the Goldilocks zone, and the moon is also a good example. The moon and the Earth are basically a whole system going around the sun. So it's very incredible that the temperature between the high and the low temperatures of the moon have a wide range, right? It can go to minus 100 Fahrenheit to plus 200 Fahrenheit on the, or nearly 200 Fahrenheit high on the moon. And that's because of the lack of atmosphere. Okay. The second is with Mars. Now, the interiors of the terrestrial planets slowly cool as their heat escapes. Makes sense. This cooling gradually makes the lithosphere. Remember that we talked about the wrinkles in Mercury? That's because of the cooling, the rapid cooling inside. So there you are, right? And moves molten rocks deeper towards the outer core. Larger planets take longer to cool, and thus larger planets retain molten cores longer, have thinner and thus weaker lithospheres. The lithosphere and the xenosphere are like the upper part of the mantle, between the crust and the mantle, okay? So we are not technically on the lithosphere, sort of, right? We are on the crust, remember that. So volcanoes in the surface of Venus, we have lava, right? That happened due to impact craters, right? Producing those volcanoes. So we have some activity in there. So here are some photographs of Venus from the Venera landers, right? So the atmosphere of Venus. The atmosphere of Venus is very dense. It has a solid cloud bank of from 50 to 70 kilometers above the surface. And as I said, the atmosphere is mostly carbon dioxide. The clouds are sulfuric acid. Look at that. Look at the temperature, how high it can get on the what we will call the troposphere. 750 kelvins. Yeah. 750 kelvins, guys, by the way, is around 500 degrees Celsius. Is almost 5 times the boiling point of water. No wonder, right? No wonder. Now, you probably have heard about the potential discovery of some sort of organic material, not life, but they are trying to look into that on here. If you guys have watched Star Wars, right, you remember the Cloud City. One of the ideas behind the Cloud City is that the surface of the cloud, what was the name of the planet? I don't remember. The planet of Lando Calrissian, right? The reason why they have those large platforms above the surface was to be on top of the clouds. So one idea is that they were able to get enough organic material from that area to survive. Now, in the movie, they talk about mining. So maybe that doesn't really work, right? Maybe they were just there because of whatever, right? Star Wars. But I remember reading that we could potentially have a base on the top of Venus's clouds. So without going into the dense atmosphere that will basically crash us to death, right? So here is the greenhouse on Earth. Here is the greenhouse on Venus. So as it says here, it just kept getting hotter and hotter as infrared radiation was reabsorbed. So nothing escaped, or almost nothing escaped. Most of it stayed here on the planet. That actually is very important when we talk about climate change, guys. Look, I don't think that will ever happen on Earth, but we shouldn't be heading towards the way where we are causing strong changes on the climate patterns or the climate systems. Global warming is a wrong term. The correct term is climate change. Why? Because you may say, well, we're getting warmer here, but in some other parts of the planet, they are getting colder. So that idea that there is a global warming was okay up until the 90s. Now we know that the correct term is a climate change, a climate shift that is happening because of the increase of carbon dioxide. Now, don't be mistaken. The biggest greenhouse gas is not carbon dioxide, it's water vapor. But if you add carbon dioxide in high amounts, in combination with water vapor, you can create a stronger and stronger greenhouse effect. So obviously we don't want that to happen here on Earth, right? For Venus, there's no magnetic field, most likely because the rotation is too slow. I already explained that. Planets with cooler interiors have thicker lithospheres, so we talked about that already. We know about crater impacts. And in the terms of Mars, we have these valleys, we have ancient rivers, not necessarily water, even though there most likely is water in Mars beneath the surface. I mean, don't be surprised if we find it in the next few years. We just found water on the moon, right? On the crater Clavius. So we probably will find it there. Mount Olympus, the highest mountain on the solar system. And here is a very nice comparison between the temperature and the dense atmosphere of Venus and the comparison with Mars and the Earth. So for the Earth, you know, we have the troposphere, stratosphere, mesosphere, and thermosphere. For Venus, we have these layers. We don't really call them the same, although you can say that this is the troposphere here. And in the case of Mars, you see how different it is. This is around what? 260? 260 Kelvin is minus 10 degrees. So it gets extremely cold most of the time. Mars is very cold and dry because of the lack of atmosphere, right? It's very thin. It's mostly just random carbon dioxide ice clouds, right? Not much to say about that. Now look at the atmospheric pressure. For us, it's just 1 atmosphere. For Venus, it's around 90. For Mars, it's 0.00. It's like nothing, right? So it's something to think about, right? It's something to think about. So for the atmospheric circulation of Venus and for the Earth, right? As I said before, right? The rotation of a planet does play a vital role on this. Venus rotates very slowly. So the sun warms the equatorial regions and you just have a northern cell and a southern cell. So you have just 2 convection cells. Remember convection, right? Convection currents, hot air goes up, cool air goes down. In the case of the Earth, because the Earth rotates much more rapidly or more rapidly than Venus, you have different cells. You have 6 of them. Northern and southern polar cells, you have the northern hemispheres and the tropical cells. The circulation that, is different, which we can explain by having different weather systems in different parts of the Earth. So right now here is getting towards winter. On the equator, they are nicely enjoying warm weather, right? And on the south, they are going towards summer. So honestly, guys, the rest is just a few pictures, and then you can always go down here and read more information about the Martian atmosphere. Actually, you can take a look at how we may have revelation of water on Mars by different impacts. If we compare craters in 2009 and 2009, there are signs of ancient Martian water, okay? And we have here some of the missions on Mars. And basically the idea is to explore the surface of it, okay? To understand if there was life, we're looking for organic material, evidence of water, all right? We explore the rocks and their composition. So there have been many rovers going to Mars to explore the planet. No man mission yet on the horizon. Read these, guys. I like this because it shows you that Mars, even though it has an ancient evidence of tectonic plate activity, we know it has weak gravity. So obviously, light elements like hydrogen and helium escape, right? Like here on Earth. Now you have water vapor, carbon dioxide, nitrogen that were outgassed from Martian volcanoes. Now, sunlight warms Mars less than Earth, so the water fell as rain. Carbon dioxide is dissolving water. Removing the carbon dioxide and water from the atmosphere reduces the greenhouse effect, lowering the temperatures. Water froze beneath the surface. So maybe water there, right? While carbon dioxide went into rocks and regolith. All right. Oxygen sulfuric, right, as well. Now you have ultraviolet light from the sun broke apart. So the ultraviolet light is the one that broke apart the water molecules and nitrogen molecules. And the weak gravity allows hydrogen, nitrogen, and oxygen atoms to escape. So this is very important to understand. And then you have the same for Venus here. And that's it. Okay. The next evaluation, guys, will be the exam that will include what? Mini course number 2, telescopes, introduction to the solar system and formation, the Earth, crater wars, Moon and Mercury, Venus and Mars. All right. I'll be publishing that exam later this week. No, sorry, this weekend, because I'm doing this on Friday. And you guys will have enough time to complete it. All right. Good luck. we just have to discuss about the Jovian planets, the asteroid belt, and maybe talk a little bit about the sun before the final exam on December. All right, guys, see you later. Have a good rest of your weekend.